नागेश, नागेश, नंदीश, नंदीश, पूजा,
Present, sir.
पूजा,
Present, sir.
okay, right. प्रमोद कुमार, प्रमोद कुमार, प्रवीण, प्रवीण, प्रियंका, प्रियंका, राहुल, संध्या, संध्या, संतोष पुजारी, संतोष सोनार, शाहबाज, शफिया, शशिधर, श्रीधर सोलकनौर, सृष्टि बर्मनौर,
Present, sir.
राइट. सिद्धार्थ वर्णेकर, सिद्धार्थ वर्णेकर, सिद्धार्थ पाटिल, सिद्धार्थ पाटिल, सुप्रिया करदण्णवर,
Present, sir.
राइट. वंदना, वंदना, वसंत, वसंत, वेदत्ता, योगेश, महेश, बालेश, तैक मोहम्मद, तैक मोहम्मद, प्रवीण राठौड़, अभिषेक,
Present, sir.
ओके. ऐश्वर्या,
Present,
ऐश्वर्या,
sir.
राइट. अमानुल्ला, अमानुल्ला, बंडुरकर तनय मोहनदास, बावराव, शोधन,
Present, sir.
ओके. देवनार अनिल कुमार शेखप्पा, देवनार अनिल कुमार शेखप्पा, नंद कुमार, नंद कुमार, प्रमोद, रोहिणी,
Present, sir.
राइट. रोहित अलवाणी, रोहित अलवाणी, शशिधर, श्रीधर,
Present, sir.
ओके. साइश, साइश, स्नेहल, स्नेहल, कार्तिक पीएम, कार्तिक पीएम, वैष्णवी, वैष्णवी, anybody else, anybody else joined?
Sir, Bharti.
32. Sir, roll number 15.
Roll number 15.
Sir, USN 12.
Roll number name, roll number 15 name, Gad
Sir,
Pratmesh Shivaji.
Shivaji.
Roll number Pratmesh 15. Next
15.
USN
Bharti.
12.
Okay. Bharti done. Gad Pratmesh Shivaji. Anybody else?
Sir,
Shafia,
Shafia.
roll number
31. Sir, 31.
Okay. Right. 32.
Sir, 32.
Name 32.
Yes, sir.
32. No, what is your name? I am not getting. 32 roll number. Sridhar Solkanar.
हाँ सर.
Sridhar Solkanar is a different roll number. Okay, let it be. Okay, right.
Okay.
Anything else? Okay. You are able to see the screen?
Yes, sir.
Right. The program is like this. Write an 8051C program to toggle all the bits of P0, P1 and P2 continuously with a 250 millisecond delay. Use the XOR operator. The last class I discussed about the various types of operators: shift right operator, shift left operator, logical operators. Right? We will be discussing few of the programs on these operators. Here they are asking to toggle all the bits of P0, P1 and P2. That means from 55 you have to make it AA, and from AA you have to make it 55 with the delay of 250 millisecond in between the two shifting or in between the two toggling. Okay, that is when it is toggling after 55 you have to give the delay of 250 millisecond, then make it AA. After making AA you have to give the delay of 250 millisecond, then make it 55 like this. Okay, that is how we have to toggle the bits. But here the condition is mentioned. The condition is you have to make use of the XOR operator. You have to make use of the XOR operator in order to toggle the bits. Okay, let us see how to do this. Start from the header file. Include reg51.h. Here they are asking to give a delay of 250 millisecond. Write the delay function. Void ms delay of unsigned int. Then write the main function. Void main. Then under the main function, first write the initialize all the ports P0, P1 and P2 to 55. Make them 55. Initialize them. 0 is equal to 0x55. P1 is equal to 0x55. 0x55. Then P2 is equal to 0x55. Okay. So after initializing here, okay, then we'll make use of the while loop. While of 1, condition is always true. It will be in the infinite loop. While of 1, then we have to toggle now. How to toggle it? This is how we have to use the instructions. P0 is equal to XOR. Okay, we have to use the XOR operator. P0 XOR with we have given 55. Now we have initialized this to 55. If we XOR with what value, we will get 55. That we have to know. So we have to XOR with FF. 0xFF. If we XOR P0 with 0xFF, let us say the value in P0, it is 01010101. Okay, first value, let us take it as 010155. 0101. Now this we are XORing it with FF. That is 1 1 1 1, then 1 1 1 1. Here we are XORing here. Then once we XOR it here, what we will get? If we XOR, what will be the answer? If we XOR here, this is what we will get here. This is 1 1 1. 0 XOR 1 is 1, 1 XOR 1 is 0. This is 1, this is 0. A will get correct. 1, 0. This is 1, 0 XOR 1, 1, 1 XOR 1, 0. We will get AA. So it has toggled. Okay. That means if we want to toggle, then we have to XOR with FF. Let us check the one more condition. That is, now it is P0 is equal to 0xFF. Fine. Next one. P1 equal to P1 XOR P1 XOR 0xFF 0xFF. Then next P2 is equal to P2 XOR with P2 XOR with 0xFF. Right. So we have toggled here. Once we have toggled, end the while loop, end the while loop, then end the main program, then end the main function. And then now we have to write the delay function. This is for toggling. P1 XOR 0xFF, it will toggle. P2 XOR 0xFF, it will toggle. Next is we have to write delay function. Void ms delay of unsigned int I time, unsigned int I time. Then define the loop indices, unsigned integer I comma j, unsigned integer I comma j, I comma j. Then write the two for loops. For I is equal to 0, I is equal to 0, I less than I time, I less than I time, I plus plus, I plus plus. Next for loop, for j is equal to 0, for j is equal to 0, j less than 1275, j plus plus, j plus plus. Okay. I is equal to 0, I less than I time, I plus plus. For j is equal to 0, j less than 1275, j plus plus. So this is the delay function. Now one more condition we have to check. If it is 55, it is toggling to AA. Next time when the while loop is entered, the second time when the while loop is entered, P0 value is AA. P0 value is AA, that is 1010, then 1010. This is XORed with FF. This is XORed with FF. 1111. This is 1111. Now how to XOR? How to XOR here? What will be the answer? See, 1 XOR 1 is 0, 0 XOR 1 is 1, 0 1 XOR 1 is 0, 0 XOR 1 is 1, 0 XOR 1 is 1, 1 XOR 1 is 0. Third bit will be 1 here. 0 1. Then this is 1 XOR 1 0. This is 1. This is 0. 0 XOR 1 1. We are getting 0 1 0 1 0 1 0 1. That is 55. This will be 55. Correct. So what we are getting here? 55. That is if we are toggling. If we are toggling from, that is 1 0 1 0 1 0 1 0. If we are toggling it, if we are XORing it with the FF, we are getting 0 1 0 1, then 0 1 0 1. Okay, 0 1 0 1 0 1 0 1. That is 55 we are getting. Okay. It means it will go on toggling from 55 to AA and from AA to 55. This will continue until the while loop goes on repeating. Right? So you understood here how to make use of the XOR operator to toggle. Is this clear? Is this program understood? Any doubts here in this program? Any doubts in this program?
No, sir.
Okay, we'll move on to the next one. Next one, write an 8051C program to get a P1.0 and send it to P2.7 after inverting it. Write an 8051C program for what? To get P1.0 to read the pin P1.0. That means you have to make P1.0 input pin and then send it to P2.7. You have to send the pin which we have stored in P1.0. We have to invert it and then send it to P2.7. That means P2.7 is output bit, P1.0 is input bit. This P1.0 is input bit and P2.7 is output bit. Right? For this, we have to write a C program. Simple program. Start with the header file. Hash include reg51.h. reg51.h. Then we have to define input bit and output bit. Input bit is P1.0. Input bit is P1.0. So it is S bit, input bit is equal to P1.0. It is P1.0. This is how we have to write P1.0. P1, then you have to use the XOR operator. It is not the XOR operator, it is inverting V, then P1.0. This is how we have to write it. Similarly, output bit, S bit, out bit is equal to, use the output bit 2.7. P2 inverted V symbol, then 7, P2.7. Okay, this is the way of writing P1.0. P1, then inverted V 0, P2.7, P2 inverted V, then 7. Then we have to invert the bit. For storing the inverted bit, we have to define that also. Bit memory bit, bit memory bit. Then write the main function, void main. And in the main function, very simple program. First, we have to make this P1.0 input pin. If you want to make it input pin, we have to store 1 in that pin or 1 on that pin. This 1 should be stored. Pin bit is equal to 1. That means this P1.0 will become the input pin. P1.0 will become the input pin. So that whatever value is stored on that, that will be read into the microcontroller. In bit is equal to 1. We are configuring the port pin here in bit, that is P1.0 as input pin. Once you have made it as input pin, what they are saying, read the program statement. To get P1.0, read the bit stored on P1.0, invert that bit, that is make not of that bit, and then send it to P2.7. Now first read the pin P1.0. To read the pin P1.0, how to read it? Mem bit is equal to which bit? In bit. Mem bit is equal to in bit. In bit is input bit, that is P1.0. Whatever value is stored on P1.0, that will be stored in mem bit. That is this. Here we are defining it as bit. Okay, it is not a special function register. P1.0, these ports are special function registers, whereas this is a variable. Mem bit is a variable, it's a single bit variable. You have to define it as bit. Clear? Mem bit is equal to in bit. That means whatever value is stored on in bit, or whatever bit is stored on in bit, that will be assigned to mem bit. That will be assigned to mem bit. Single bit variable. Now what we have to do next step, we have to invert this bit and assign to out bit. Out bit is equal to not operation, not of mem bit, not of mem bit. Suppose say in the in bit on P1.0, the bit is say 0. Now then mem bit will be equal to 0. Mem bit is equal to 0 if the bit on P1.0 is 0. If P1.0, if P1.0 is equal to 0, then that will be in bit. In bit we are assigning it to memory bit. Mem bit is equal to 0. We are performing not operation on bit stored in mem bit. That is 0 will become 1. 0 will become 1. Right? And then this will be assigned to out bit. This will be assigned to out bit. Here, this is how it will perform reading of the bit from the pin. It will invert that bit. It will perform the not of that bit, and the result will be stored in one of the output pins. Okay. This is the logic of the program. Once the logic of the program is completed, end the main function. Before this, after the main function, we have to repeat it for indefinite number of times. If we are repeating, then we have to make use of the while loop, while of 1. First end the while loop, then end the main function, then end the main function. Is it understood here, students, how to write the program for reading the pin? For reading the pin, once the value on that pin is read, once the value on that pin is read, then invert that bit, take one's complement of that bit, invert the bit, and then send it to P2.7. Right? I hope this program is understood to everyone. Yes.
ಸರ್ ಇದು ಹಳೆ ಪ್ರೋಗ್ರಾಮ್ ಡೌಟ್ ಇತ್ರಿ ಸರ್.
ಏನ್ ಡೌಟ್ ಐತ್ರಿ ಮಂತೇಶ್?
ಸರ್ ಅದ್ರಾಗ 250 ಮಿಲಿಸೆಕೆಂಡ್ ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿದ್ರಿ ಸರ್ ಅದ್ರ ಪ್ರೋಗ್ರಾಮ್ದಾಗ.
ಹೌದ್ರಿ, ಅದ್ ನಾವು ತಗೊಂಡೇವ್ರಿ ಡಿಲೇ ಅಲ್ಲೇ. ನಾನ ಅದ್ರ ನಿಮ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಮಾಡೋ ಸಂಬಂಧ ಡಿಲೇ ತಗೊಂಡೇನ್ರಿ ಅಲ್ಲಿ.
ಹಾ ಸರ್, ಬಟ್ ಅಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಿಲ್ರಿ ನಾವು ಪ್ರೋಗ್ರಾಮ್ದಾಗ ರೀ.
ಸ್ಟೇಟ್ಮೆಂಟ್ ಹೇಳತ್ತೀರಿ ನೀವ?
ಹಾ ಸರ್, ಆತ್ರಿ ಆ ಸ್ಟೇಟ್ಮೆಂಟ್ ದಾಗರು ಕೊಟ್ಟಾರಿ ಸರ್. ಅದ ಪ್ರೋಗ್ರಾಮ್ ಒಳಗ ಮೆನ್ಷನ್ ಮಾಡಿಲ್ರಿ ನಾವು MS ಡಿಲೇ ಆಫ್ 250 ಅಂತ್ರಿ.
ಮಾಡಿಲ್ಲನ್ರಿ? ಮಿಸ್ ಆಗೈತ್ರಿ ಸ್ವಲ್ಪ ಅಲ್ಲೇ. ಅದ ಅಲ್ಲಿ ಇನ್ಕ್ಲೂಡ್ ಮಾಡ್ಕೊಡ್ರಿ ಅಲ್ಲಿ ಮಿಸ್ ಆಗಿತ್ತು ಅಂದ್ರ. ಯಾವ ಪ್ರೋಗ್ರಾಮ್ ಅದು
ಸರ್? ಇದರಿ ಇದ್ರ ಮ್ಯಾಗ ಐತ್ ನೋಡ್ರಿ ಅದು.
ಇದ್ರ ಮ್ಯಾಲಿಂದ್ರಿ ಇದ ಪ್ರೋಗ್ರಾಮ್
ಹಾ ರೀ.
ಇಲ್ಲೇ ರೀ. ಒಂದ್ ನಿಮಿಷ ರೀ. ಹಾ, ಕರೆಕ್ಟ್. ಫೈನ್. ಇಲ್ಲಿ ಏನಾಕತ್ರಿ ಮಂತೇಶ್? ಮೆಸ್ ಡಿಲೇ ಆಫ್ ಅನ್ಸೈನ್ಡ್ ಇಂಟ್ ಕೊಟ್ವಲ್ರಿ. ಒಂದ್ ನಿಮಿಷ ರೀ. ಹಾ, ರೈಟ್. ಇಲ್ಲೇ ಇಲ್ಲ ಆದ್ಮೇಲೆ ಇಲ್ಲಿ ಕೊಡು. ಇಲ್ಲಿ ಈ ಡಿಲೇ ಆಕ್ಕವಲ್ರಿ ಇವು ಮೂರು ಆದ್ಮೇಲೆ ಇನ್ ನಾಟ್ ಎಕ್ಸಾರ್ ಆದ್ಮೇಲೆ ಕೊಡೋಣಂತ್ರಿ ಇಲ್ಲಿ
ಹಾ ಸರ್.
MS ಡಿಲೇ ಅಂತ ಥ್ಯಾಂಕ್ ಯು MS
Yes.
ಡಿಲೇ ಆಫ್ 250 ರೈಟ್. ಅವಾಗ ಏನಾಕೈತ್ರಿ ಇದು ಎಕ್ಸಾರ್ ಆಪರೇಷನ್ ಟಾಗಲ್ ಆದ್ಮೇಲೆ 250 ಮಿಲಿಸೆಕೆಂಡ್ ಡಿಲೇ ತಗೋತೈತ್ರಿ. ಮತ್ ಇಲ್ಲಿ ಬರ್ತೈತ್ರಿ ಬಂದ್ಮೇಲೆ ಅಗೇನ್ ಇಟ್ ವಿಲ್ ಕಮ್ ಬ್ಯಾಕ್ ಅಂಡ್ ಅಗೇನ್ ಇಟ್ ವಿಲ್ ಟಾಗಲ್ then again it will give a delay of 250 millisecond, again it will toggle, this will continue. Starting, this is initialization portion. This is initialization portion. Here what will happen? It will toggle and then it will give the delay. Okay, right. This second program is clear, students? This one is clear? This one is clear, second one? Bhakti, is it clear, this program?
Yes, sir.
Okay. Abhishek, is it clear? Palekar, Aishwarya,
Yes, sir.
understood program?
Yes, sir.
Right. Sridhar, Badiger?
Yes, sir. Understood, sir.
Okay, fine. Let us move on to the next program. Write an 8051C program to read the P1.0 and P1.1 bits and issue an ASCII character to P0 according to the following table. Note down this program statement. Write an 8051C program to read the P1.0 and P1.1 bits and issue an ASCII character to P0 according to the following table. Note down the table also. P1.1, P1.0. That means if P1.1 and P1.0 are 0, 0, you have to send 0 to P0. If P1.1 is 0, if P1.0 is 1, then you have to send 1 to P0. P1.1 is 1, P1.0 is 0, send 2 to P0. If both are 1, then send 3 to P0. Note down the table as well as the program statement. Is it taken, students? Noted down?
Yes, sir.
Okay, we'll proceed. Read the program statement. Write an 8051C program. It is clear that you have to write 8051C program only, not the assembly program. To read the P1.0 and P1.1 bits. That means these two bits we have to read from the port pins. Okay, that means these two pins we have to make them as input pins, or port 1 we have to make as input port, and we have to read only these two pins. Among the 8 bits, we have to read only the two pins, P1.1 and P1.0, and issue an ASCII character to P0 according to the following table. That means if both are 0, send 0 to P0. If it is 0, 1, send 1 to P0. If it is 1, 0, send 2 to P0. If it is 1, 1, send 3 to P0. Okay. Read P1.0 and P1.1. If it is 0, 0, send 0 to P0. If it is 0, 1, send 1 to P0. If it is 1, 0, send 2. If it is 1, 1, send 3 to P0. Let us look into the details of this program. We'll write it down. Header file at the beginning. Hash include reg51.h. Hash include reg51.h. Then next one, we have to define the main function. Is there any delay here? There is no delay as such. Write the main function. Void main. Then here define a variable. Here we'll be making use of switch case statement. Okay, it is switch case statement we are making use of here. Let us define a variable for the switch case statement. Unsigned character z. Unsigned character z. Then we have to make port P1 as input port. Make port P1 as input port. So P1 is equal to 0xFF. 0xFF. We have made the port P1 as input port. Okay. Now we have to read the value from the port P1. Now we will give Z is equal to P1. We are configuring the port as input port. This P1 we are configuring as input port. Once it is configured as input port, whatever value is read on P1, that will be stored on Z. Z is equal to P1. Right? Then we have read the value. Suppose say the value on P1 is 35. Value on P1 is 35. That is 35 is equal to 0011. Then 5 is 0101. Okay. So we have read this value 35, which is stored on port 1. Now what we want here? We want only P1.0 and 1.1 according to the table here. Look at the table. It is only P1.1 and P1.0. We are not interested in the remaining bits. Only the least significant bit and the next bit. These two bits we are interested. Okay, we don't want the remaining bits data. Okay, so if we don't want the remaining bits data, then what we have to do here is P1 is equal to Z is equal to Z and with 0x. Now if we AND this value with what value, we will get only the 2 bits, least significant 2 bits. Can anybody make a guess? If we AND with what value, right, we'll get the least significant 2 bits. Yes? Think. If we logically AND the 35 with what value? Okay, with what value? We'll get only these 2 bits. 0, 1 I should get, least significant 2 bits. 0, 1, these 2 bits I should get. So if I AND with what value, I will get these 2 bits, 0, 1. I have to AND it with 3. I have to AND it with 3. See here how it will work. So here 35 will be ANDed with 03. That is 0, 0, 0, 0. Then 0, 0, 1, 1. Okay, 0, 0, 0, 0, 0, 0, 1, 1. Logically AND them. What we will get if we AND them? Yes, check. So this is AND operation. 0 and 0 is 0, 0. 1 and 0 is 0. 1 and 0 is 0. Then this is 0. This 1 and 0 is 0. 0 and 1 is 0. 1 and 1 is 1. What we are getting the last 2 bits? All the bits we are getting 0 because we are ANDing with 0, 3. Right? Only these 2 bits, that is P1.1 and P1.0, that is 0, 1 here. Whatever is there here in the data, the same we are getting here, that is 0, 1. Yes or no? That means we have to AND it with 0, 3 so that whatever P1.1 and P1.0 is there, the same we will get. Okay, that we are storing in Z. Then once we got that, next we have to switch case statement. We have to make use of switch case statement. Right. Next we'll make use of switch case statement. Switch, because it is based on this value P1.0 and P1.1. What we are getting here, 0, 1 we are getting. So switch of Z, switch of Z, switch of Z. Then case 0, case 0, case 0, colon, then into bracket, P0 is equal to 0, P0 is equal to 0, put it in single inverted mark, okay, single quotes, then break. That means if the value of this Z, right, it is 0, then P0 will be equal to 0. Here P0 will be equal to 0 means it is actually not displaying 0. It will display the ASCII value of 0. It will display the ASCII value of 0. ASCII value of 0 is 0 plus 30. 0 plus 30. It will add 30 to that. 30 is the ASCII value of 0. 30 will be displayed on port 0. Okay. Because the program just statement itself will go like that. See, write an 8051C program to read P1.0 and P1.1 bits and issue an ASCII character. Issue an ASCII character to P0 according to the following table. So what will happen here? Even though it is 0, what the microcontroller will do? It will add 30 to that, and 30 will be displayed in binary on port P0. 30 will be displayed in binary on port P0. Okay. So it is 30. Then next, end this loop here. End this. And next, case 1, colon, if Z is equal to 0, 1, as in our example that we have taken now. What we are getting here, 0, 1. P1.1 and P1.0 are 0, 1 here, 35. Okay. So if it is 1, then what it will do? If it is 1, then P0, correct? P0, right? Yes. P0 is equal to 1. Put it in single quotes, semicolon, then break. Out of the loop. Once it is break, it will immediately come out of the loop. Okay. Then close this. Next, suppose if the case is, or if the condition is 2, if the value is 2, the value of Z, if it is 2, the value is 2, then what will happen? The value is 2, case 2, colon, then P0 is equal to 2, P0 is equal to 2, right? Then break. Now here P0 equal to 1 means 1 will not be displayed. ASCII value of 1 will be displayed. That is P0 is equal to 1 plus 30. 1 plus 30. That will be 31. Right? ASCII value will be displayed. Similarly here, P0 equal to 2 means P0 will be equal to 2 plus 30. 2 plus 30. That is 32 will be displayed. 32 will be displayed. And next, what is remaining? What else is remaining? Case 3, third condition. Okay. Case 3, case 3 colon case 3 colon P naught if the value of Z is 3. That means if P1.1 and P1.0, the value read from P1.1 and P1.0 pins, the data it is, okay? The data read from P1.1 and P1.0, if it is 0, 3, that is 1, 1. If both the pins are 1, P1.1 and P1.0, if both are 1. See that table here. P1.1 and P1.0, if both are 1, then we have to send 3 to P0. Send 3 to P0. Case 1, case 2, case 3, send P0 to equal to 3, P0 equal to 3. Okay, then semicolon, break. Okay, then end the case, that is that loop here, case 3, case 2, case 1, case 0 are ended. You have to end the switch statement first. So switch of Z, we have to end it here. Then we have to end main loop. Okay, we have to end switch and main loop. So here we'll be having ending the switch statement, then we'll be ending the main loop. Number of opening brackets will be equal to number of closing brackets, right? This is how we are writing a program to read the pins P1.0 and P1.1 bits and issue an ASCII character to P0 according to the following table. If it is 0, 0, we are sending 0 plus 30. 30 will be sent to P0. Internally, it will perform that operation. 0, 1 means it will convert 1 to 1 plus 30. 31 will be stored on P0. 1, 0 means 2, that is 2 plus 30. 32 will be sent on P0. 1, 1 means 3. 3 plus 30. 33 will be stored on P0. Okay. So this is how the program has to be executed. Is this program understood here, students? This program is clear here. Third one. Is this understood here, students? This program?
Yes, sir.
Okay. Right. Akshata? Bhagyashree? Is it understood, Bhagyashree?
Sir, I'm
You are not understood?
understood, sir.
Understood. Okay, fine. Bhakti?
Yes, sir.
Clear, Bhakti?
Yes, sir.
Right. Bharti? Bharti? Gat Pratmesh Shivaji? Gat
Yes,
Pratmesh
sir.
Shivaji?
Yes, sir.
Understood, Gat Pratmesh Shivaji? Okay.
Yes, sir. Understood, sir.
Fine, fine. Jyoti? Mantesh?
हाँ सर क्लियर सर.
Okay. Pooja?
Yes, sir.
Right. Nandish? Okay. Mute your cell phones. Somebody's cell phone is on. Mute your cell phone. Shabaz? Shafia? Jagdal? Is it understood, Shafia? Srushti? Is it clear? Understood? Good. Okay. Supriya?
Yes, sir.
Right. Aishwarya?
Yes, sir.
Understood, Aishwarya?
Yes, sir.
Right. Abhishek? Abhishek? Shodhan? Devanar Anil Kumar Shekappa? Devanar Anil Kumar Shekappa? Sridhar? Badiger?
Yes, sir. Understood, sir.
Understood. Good. In the next class, we'll continue with few more programs on the logical operators, and then we'll take up the next topic, right? Thank you.